Open a terminal window. On Windows, that's CMD or PowerShell. On Linux or Mac, use your usual terminal. And if you're using Docker Desktop, if you want it, there's also a built-in terminal in there that you can use. Nearly all Docker commands start with the Docker keyword. If you forget a command, just type Docker on its own, and it gives you a full list of options. A cheat sheet of these is also available through Patreon if you want something to keep handy. The docker run command is how we start a container. Here we're running one called Hello World. That name at the end is the container image, a downloadable file that Docker uses to create and run the container. Because we don't have this image locally, Docker automatically pulls or downloads it from a registry. We'll look at registries very soon. After the image name, you'll notice a colon followed by a word. That's called a tag. Don't worry about that just yet. We'll cover that in just a moment. And there it is. Hello from Docker. The container ran successfully. This is a deliberately simple container. It just starts, prints a message, and stops. Some containers are like this. That is, short-lived, running just long enough to do a specific job. Other containers, like web servers, will run continually until we tell them to stop. Let's look a bit deeper at images. The docker image list command shows all the images that have been downloaded to your local machine. The repository is the logical name of that image. It is often in a user/image name format, which I'll explain further in a moment. So where do images come from? Downloadable images are stored in registries. Think of these like an app store for containers. When Docker needs an image, it pulls it down from the registry. One of the biggest of these registries is Docker Hub. It has thousands of publicly available images from companies and individuals all around the world. There are other registries too. Some are public, some are privately hosted. But Docker Hub is where we will spend most of our time. Here, we're looking at the Traefik account on Docker Hub. Traefik is a company that builds load balancers and edge routing tools. Notice that they have multiple repositories. Each one is a collection of related images under their account. Let's look at one called Who Am I? It's a very simple test container and a very useful one for learning. Inside the repository, we can see multiple versions of this image. These versions are identified by tags. A tag might represent a version number, a processor architecture like x86 or ARM, or it could really be anything the developer chooses. One tag you'll almost always find is latest. This is exactly what it sounds like. It's what you get when you don't specify a particular version. A full image name tells us a few things. This full image name tells us a few things. In this case, Traefik is the account owner. This is the user or company on the registry. Who Am I is the image name. Together, Traefik/Who Am I is the repository. This is the combination of the account and image name. And latest, after the colon, is the tag. We can download an image without running it using docker pull. If you leave off the tag, Docker assumes you want the image with the latest tag. And there it is in our local image store. We still have the Hello World image sitting around. Let's clean that up. The docker image rm command removes an image from the local system. One thing to keep in mind, you can't remove an image if a container built from the image still exists, even if the container has been stopped. In that case, you need to remove the container first, and then you can remove the image. Let's start a container from this image. From the output, we can see that it's running on port 80. That's because this container is a simple web server. It's important to understand that this is port 80 inside the container. It's not yet accessible from the outside. We'll fix that shortly. Unlike the Hello World container, this one runs continuously, meaning it won't stop until we tell it to, or until something goes wrong. Right now, it's also running in the foreground, which means our terminal is tied up. Press Ctrl+C on your keyboard to stop it. In most real-world scenarios, we don't want a long-running container blocking our terminal like this. Adding the -d parameter starts the container in detached mode. It runs in the background, and we get our terminal back for our own use. The string that's printed is the container's ID, and we'll use that in just a moment too. The docker ps command shows all running containers. For each container, we can see its ID, which is a shortened version of that string we saw a moment ago, the image that it was built from, the current status of the container, the entry point. This is the command the container is running internally. We'll explore that a bit more in a future video. The ports that are being used inside the container, and the container's name. Docker assigns a random one if you don't set one yourself. To stop a background container, use docker stop followed by either the name or the ID. Docker ps now shows there are no running containers. However, the container itself still exists. If we run docker ps-a, the A meaning all, this shows stopped containers too. Here are the two instances of the container that we previously started, the one that was detached, and the first one that we had to stop interactively. We could restart either of these if we wanted to, or we could clean them up. Let's remove them. We use docker rm followed by the ID to remove this container entirely. Note that's just the container that gets removed, not the image as well. If we know the name of the container, we can alternatively use docker rm followed by the container's name. So the container is listening on port 80 internally, but that port isn't yet reachable from the outside. To change that, we need to map a port on the Docker host through to the container. We do this with the -p parameter. The format is outside:inside. The first number is the port on the Docker host. The second is the port inside the container. In this example, both are set to 80. But you can use different values if you want a simple NAT. For example, exposing port 8080 externally, while the container still runs port 80 internally. Now the Docker host is listening on port 80 and forwarding traffic to port 80 inside the container. So let's test it. I'm running Docker Desktop locally, so I can browse straight to localhost. And there we go, a simple page returned by the container. This particular container shows information from the container's own perspective, including its internal network details. We will dig into container networking properly in a future video. We've seen short-lived containers and long-running background containers. What about interactive ones? Let's try running a Ubuntu container, a container that's loosely based on the popular Linux distribution. I've added two new parameters here. rm tells Docker to automatically remove the container once it stops, saving us the manual cleanup step later. Name gives the container a friendly name instead of getting a randomly assigned one. Now, when we run docker ps-a, we notice that the container isn't present. So what happened here? This is an interesting case because this container doesn't have a predefined entry point. That is, it starts up It has nothing to do, so it immediately exits. Some images will come with an entry point already configured, like the web server that we ran earlier. Others, like this one, need us to provide an entry point. That is, it needs us to tell it what to do when it starts. This time, we're telling the container what to run. /bin/bash. That is, the bash shell. We've also added IT as a parameter. This is actually two parameters combined. I means interactive mode, and T means a pseudo terminal. Together, they let us type commands and get responses back, just like an SSH session. Notice that we're not using detached mode here. This is because we want to interact with this container directly, not send it to the background. And now we're inside the container's shell. Let me exit that so I can try a slight variation. This time we're going to start it in detached mode. So it will run in the background, waiting for our input. Running docker ps confirms that it is there and it is still running. Even though it's running in the background, we can still send commands to it using the docker exec command. When we use this, we include the container name, that's the container, not the image, followed by the command we want to run. And if we want a full interactive session, we can use docker exec-it, followed by the container name, and /bin/bash. Now we're inside the container's shell, even though it's running in the background. One important caveat: not all containers support this. Some are built for a very specific singular purpose and have had the shell removed entirely to keep the image as small and as secure as possible. In those cases, you can't use docker exec to get into a shell. I've built a full Docker course specifically designed for the network engineer's mindset. It contains hands-on labs and real-world examples. The link is in the description.